When people first started to program computers, they programmed them using a very structured approach to the code. They even gave the code line numbers. Here is an early programming language called BASIC. Some of you had me for multiple classes, and you may have gotten the opportunity to see maybe multiple times Pirates of Silicon Valley, where Bill Gates talks about the development of BASIC as one of the first programming languages available to people, to average people, to code, rather than the very complicated assembly programming language and other programming languages like Fortran, COBOL, that were available at that time, which were really, really hard to learn. So a programming language like BASIC, which is accessible and more, looks more like the way humans communicate, had a really structured approach. And the program would run code from the top, line 10, through the lines of code, implementing one line at a time, unless it got stuck in a loop. Like on line 50, there was a for loop, and it would repeat the commands between line 50 and line 70 for that for loop. And or unless it had a go-to statement, which would send it to another line. Like on line 120, you see something that says go to line 30. I used to program in BASIC, actually. And the reason we counted by tens is because if we decided we wanted to add something between line 10 and 20, we could type 15 and add a new command that when our program compiled or ran, it would go 10, 15, 20. But even with 10 lines of mistakes for a future expansion, we still would have trouble. And so then we would just write a go-to statement and go to another part of the code and then come back to the line. So maybe if I ran out of space on line 19, I would say go to line 1000. And on line 1000, I'd write some code. And at the end of that block of code I needed, I would then say go to 20. And that's the way we would write code in the day. That code got a nickname. It started to be called spaghetti code, because following that code and reading that code was like following spaghetti on a plate of spaghetti with noodles going everywhere. It was very, very hard to read, very, very hard to use. They needed to come up with a different way to write code, and they did. It was object-oriented programming. Object-oriented programming allows you to organize your code into objects that do one thing. And then you go to those objects, and those objects are organized so that you can use those objects, you can change those objects, you can also inherit those objects, you can reuse those objects. It's just really handy, really well organized, and it's just a much better approach to programming than what ended up being spaghetti code. And this is a critical skill. And the chapter I'm going to ask you to read is called A Trip to Objectville. And this is from the book I'm actually assigning you at the end of the class. You're going to Objectville, and you'll leave that procedural, structured programming behind for good. It's kind of cool. And as you can see, the book itself is very, very, lots of pictures, comics, fun things. It's really not 21 pages of reading. It's a light, easy, fun read. It's pretty cool. I'm going to just show you a video from a articulate speaker on what object-oriented programming is.
Not OOPS, OOP. Object-oriented programming is a programming language model for software design that revolves around objects or data instead of logic and functions. In other words, it focuses on what developers want to manipulate rather than how they want to manipulate them. This approach is well suited for programs that are large, complex, and actively updated or maintained. An object can be anything from a physical entity, like a human being, down to a small computer program, like a widget. Object-oriented programming, or OOP, is based on four main principles: encapsulation, abstraction, inheritance, and polymorphism. Simula is credited as the first OOP language, and the most popular today are Java, JavaScript, Python, C++, and Ruby. OOP boasts benefits like code reusability, scalability, and efficiency. And due to the organization of an object-oriented program, it's also conducive to collaborative development where projects can be divided into groups. However, the method has been criticized by developers as well, citing concerns like overemphasizing the data component of software development, ignoring the computation and algorithm components, the complexity of writing OOP code, and the time to compile. Alternatives to object-oriented programming include functional programming, structured programming, and imperative programming. Many advanced languages give developers the option to combine them. Do you prefer object-oriented programming over the other methods? Let us know why and why not, and remember to hit that like button. Not oops, OOP.
Kind of a fun video there. That person, again, these are 30,000 view things. Don't worry if you're like, I don't know what encapsulation is. Was I supposed to learn that in that video? Do you know what's really fun is you are going to learn about encapsulation. You are going to learn about inheritance big time. We're going to spend a lot of time on inheritance. And you're going to learn about even this thing called polymorphism. So you're going to be kind of experts on those three concepts for sure by the end of this class. Doesn't it just sound fun to say polymorphism? Which, by the way, is when you inherit an object, the object use it, and you have an original object, and then a parent class, and then a child class, and a child inheritance properties of the parent. The child knows how to behave based on polymorphism. So confusing, sorry, that didn't help. I thought it would be impressive, but when I said it, it didn't sound that impressive. I just want to take you off the hook a little bit here and explain to you the instructional model that you're being exposed to in this APCS8 class, which is known as an objects first approach. And what's going to happen with an objects first approach, which is the paradigm I use to teach this class. People who've taken this class in the past, I had an objects last approach. Now I'm going with an objects first approach, and so is the AP. The AP calls this topic 2 for a reason. They have ruled that an object first approach is the best way to teach new coders, so I'm going to follow their lead. Objects, we're just going to cover an overview in this unit that we're going over from now until Thanksgiving. We're not going to do a deep dive. You're not even going to have to memorize the code to create a class yet. You're going to see classes, and I'm going to show you them, but you're not going to have to memorize it until topic 5. In topic 5, you're actually going to have to memorize that you put your ivars, then your constructor, then your overloaded constructor, then your setters and your getters, then your methods. You're going to have to memorize and know how to do all that stuff in topic 5. In topic 2, all you have to learn is how to use them. You're going to learn about how to use objects, like string is an object. All the strings you create are an object, which means you can use dot operators. There is a math library that you get for free. And that math library lets you do all kinds of cool things, from using random numbers, absolute value, pi, all these cool features that are built into dot operators for math that we're going to use, and all these cool dot operators for strings that we're going to use. So we're going to learn how to use objects, even though we're not learning how to write classes yet. So we're just at the beginning of learning about object-oriented programming today. I hope I don't overwhelm anyone or discourage anyone. But I want to quote from 5 Steps to a 5, a textbook that we have in our computer science classroom that hopefully you'll get a copy of second semester when we're studying for the exam more. They say, this is a big one. If you don't understand this concept, you will fail the AP Computer Science exam. This chapter introduces you to the most fundamental object-oriented features of Java. It explains the relationship between object and class. It also describes the simplest form of class with minimal requirements to make one. More advanced concepts of classes and objects will be discussed in chapter 7. So we are going to talk about these basics, and their concept 7 is our topic 5. So we will be doing more later as well. But this is just the introduction, and it's kind of fun. I want to throw some terms at you that I know right now are going to be meaningless, but we are going to play a gimkit with these, and then we're going to be using these words in everyday conversations about our code. So I just want to introduce them kind of quick. A class is a blueprint for an object. So we define a class. You've already been defining classes, by the way. Your first line of code that you write when you write a Java program is public class main. You are declaring a class named main, and you're declaring it public, meaning it's accessible from anywhere within that project. So class is the organizing structure of Java, and every Java file is its own class. So today we're going to actually have two classes interacting, or two Java programs interacting, a student Java class and a main Java class, and you'll see how they interact. A class is that blueprint for the objects you can create by using a constructor in that class. An object is one instance of a class, and you give it a name, a variable name, and then you've created an object of that said class. For example, if you create a string name that gets Rhodey, I've created an instance of the string class. It's got a variable name of name, and then it contains the value of my actual name. If you have a building class, you can create a instance of the Empire State Building. The dog class, you can create an instance of a dog. The computer class, you could create one specific instance of a computer. And those instances would be objects. Confusing, I know, but hang in there with me. A class is not the object. The class is the blueprint that's used to create that object. So you could have a dog class. This is again from a breeding assignment I'm going to give you. You could have a dog class, and that dog class might have some attributes like the size of the dog, the breed of the dog, the name of the dog. And then it might have some behaviors, some events like bark. And then you can use that class to create or construct various dogs. So you can have the pit bull dog, the poodle dog, and the robotic dog. And you can give them a variable name, and then you can refer to them, and then you can access their attributes and change their attributes. And you can also access their events, or you can call their methods and take action with them. It's really powerful, really cool. Constructor from Bob the Builder, that's the code that creates the objects. What is so cool about being a computer programmer and being in computer science is that you can create things. You can make things literally out of thin air, right? You can type, by typing the keyword new, I can create a new object. And I can design a class, and then I can use a constructor and call it. It's tons of fun. Constructor is that line of code that creates the object. A constructor has a specific format. You tell the data type, like we've messed with ints, doubles, booleans, and strings. That's a data type. We give it a variable name. We say gets. We use the keyword new, and then we call the constructor, and then we put in default values if we want. So that's the process of a constructor. And just as a joke, here is the duck is the name of the constructor, and duck creates a new duck. Duck creates a new duck, and it would be even funnier if they said its name was Goose. So just a funny comic. Another fun word, instantiating. Ooh, doesn't that sound good? Instantiating is the act of creating an object of a given class. So I love how object-oriented Minecraft is. When you think of Minecraft, there's a class, I guarantee it. Even without having read all the code, I guarantee there is a class called block. Now, knowing that, she might have called it square thingy, but there's a class called block. And you can create different instances of the block. And then each instance of the block will have an X position, a Y position, a type it is, like is it earth, is it diamond? Is it coal? Whatever it might be. And then it's got a 3D texture map that goes with that. It's just such a object-oriented created world. And each one of those Minecraft blocks was instantiated in from a block class. Instance is just a way of saying each individual object, an instance of the block class or the student class or the dog class. That's just the word we use. All right, time for some hands-on examples or to see things a little bit. How many of you remember App Lab, right? In App Lab, we created things using object-oriented programming and you didn't even know it. In App Lab, here's the App Lab project we used to help us study the modulus and division integer math. In the App Lab, there is objects. The button is these design elements. The button, label, all of those are elements. When I click, drag, and drop them onto the screen, it instantiates one button. I can give it a name. That is an attribute. I can give it its X and Y position. Those are attributes. So the button is an element, a class. There's a big class. It's organized in a hierarchy, I guarantee it, called user interface elements, I would almost guarantee. And then their user interface element has a subclass called button, and button inherits from user interface, and then that has attributes like button, enter, the text, the color. All those are attributes of the button. And when I click, drag, and drop it on the screen, I have instantiated a new button, and it has all these attributes or properties that I can edit and change. And each button is unique. It also has a series of events. You might remember that. Those are the actions the button can take. I want to show you a class I've made in just to demonstrate Objectville. I have our main class here, and my main class has created two students. I've created lowercase CJ for Connor, and I've created lowercase MNB for Nikolai. This class also has an attribute that is the grade and an attribute that is whether they are an AP student or not. So I've created, this is the constructor. How does the computer know how to build a student? Well, I've written a class. This is a class called student, public class student. And the public class student has some attributes. It has a name attribute that takes in a string, an integer attribute that takes in a grade level, and a Boolean attribute that takes in whether or not they're an AP student. This part is called the constructor. Now, you don't have to memorize how to create any of this yet. When we get to topic 5, I'm going to tell you create a student with these attributes and these methods, and you're going to have to just crank out the code, memorize. But that's not till unit 5. So for now, I'm just showing you where it is, and the things you're going to have to memorize how to do are the constructor and dot operators, and know how to use those. This constructor loads the data in. This is a getter, which I can get the name out with the dot operator, which I'll show you in a bit. This is a method, and this right here is the most famous of all methods. Every class should have what we call a toString method. So this is the class. This magic of a class, you do not have to learn about in this unit. However, in this unit, you're going to have to learn how to create objects of a class. And the example, when you're given the information you need, and you will be, for example, if I wanted to create a new student, I'm going to go to the meeting, and I'm going to grab whoever's first on my screen. Sorry, David. I'm going to grab David. And now poor David is going to also be a student in my class. So I'm going to create a student, and it's David, and this is a new student, and I have some parameters. The first parameter I'm going to use is his name. The next parameter I'm going to use is his grade, and I think, David, are you a 12th grader? Nope, 11. And are you an AP student? Yes, you're in this class, so you're an AP student. So I have now, through the power of computer science, just created a new student named David. There is now a new student named David. Now, no data about David has been displayed. It's the classic tree falling in the woods. David has been created in memory, but I haven't done anything to seed David's data. So now I'm going to use these dot operators, and I'm going to system out information about David. Watch how this works. I am going to set the dot operator variable to get from DS, from David. I'm going to set it to get the method called toString, the most popular string, the most popular method there is in the string. So my toString is set up so that if I call toString, it's going to return his name, his grade level, and it's going to say the word grade and is an AP student, just like this over here. Connor is a 12th grade, that sounds weird, is in 12th grade, sorry, and is an AP student, true. So it's going to do the same thing now for David. Let's see if it works. I'm going to do a system out. I'm going to system out the dot operator. Here we go. Now I have David is an 11th grader and he's an AP student. I now, with just 2 lines of code, or well, okay, 3 lines of code, 1 line to create David. This is the constructor. This took in information using a dot operator. You may have messed with these a little bit in JavaScript, but the way it works is you just take the name of the instance of the object, which is DS, you put a dot down, and then you can access its methods. And DS has other methods too, and here we'll just say like this string name. Oh, I already used that, so I'm going to just go string n equals DS. And then I also have another custom one for a student called get name. I made a get name getter, and I now can get his name. I can string out and just get his name. Little concat, oops, it's just n. Little concatenation there. And now when I run that code, I get just his name out. Pretty cool, pretty powerful, pretty much like magic, right? You have these classes, and these classes are coded. You write some specific type of code to create a class, and Java has given you some code for string already. So the string class has been written, and we're going to use it a lot in some lessons called string theory coming up. We're also going to be using the math class, where we're going to be doing math operations using dot operators in math. So some really cool stuff coming up using object-oriented programming principles. Now I am going to challenge you a little bit. I want to try using a brand new tool that was taught to me by, or taught to our group through an email from Mr. Murley. Mr. Murley really likes this whiteboard thing, and when he was describing it, I'm like, I've got to try that with my Java class. So I'm going to make it easy for you all to get there by getting you there 2 ways. One will be GoGuardian. I'll activate GoGuardian here. I didn't even have it on yet. Okay, we got GoGuardian, and let's see here. I'll send you the link via GoGuardian. I'll put the link in the Meet. And I'm going to beg you to go to this link if you're able. I know computers are computers in 2020. But here is the link. And hopefully you're all going to it magically through the power of GoGuardian. whiteboard not found. Oops. Here, I thought I was so clever. The joys of trying new technology. Trying again. If at first you don't succeed, never give up, never surrender. All right, let's try this one. Sorry about that. Here is the link to my new one. I didn't realize it wouldn't save from time to time. All right. In theory, you should have a whiteboard. What I'm going to challenge you to do is I'm going to challenge you to create yourself. So for me, I would be student, lowercase m, capital R, for Mr. Rohde. I'm going to get, and the key word for constructing is new student, and the student has three properties. First, the name, comma, oops, get me back in there. Then the grade, then whether they're an AP student. My challenge to you is, are you able to write a whiteboard that creates an instance of you, if it works? Does it work? I see you're there, but are you able to edit your whiteboard? Oh, sorry, folks. I don't know how this is. I thought you were going to be able to write on it. I wonder if I did something wrong.
It lets me run on mine.
Yeah. Go to the text and then click on the text and then drag down a spot and then start typing. Does that work? It might not. This is an experiment. Bose is working. Is anyone else able to write on it?
It works for me.
Okay.
It works for me too.
Same.
Some people are working, some people aren't. Huh. That's weird. I thought I'd be able to see your whiteboards, and I'm not. Well, learn new things. I can see them on GoGuardian. Oh, I can't see till you hit save. So when you're done, hit save. There it is. Now I can see them. Nice, nice. Some people are doing some constructors. Nice, nice, nice. You just wrote a constructor. Congratulations. You are Bob the Builder. You can do it. You get things done. Nicely done. I'm sorry about the new thing. It's always hard learning new stuff. I'm going to carry on with some more definitions and then a game with the definitions. Attributes, or what we're eventually going to call instance variables, or to sound cool, we're going to say ivars. Those are the properties of the class. Like for that class, the student class, we have the name, the grade level, and whether or not they're an AP student. And on a Minecraft block, you might have the X position of the block, the Y position of the block, the Z position of the block, what type of block it is, the bitmap for the block. You'd have all these attributes. You'd also have some actions like for when destroyed, what is it going to do? All that kind of stuff are examples of attributes. Instance variables are the name of, that's what we call the variables that we create that have the attributes. Methods, those are the actions that a block can take. We do have some actions that our block can take, or I should say our name can take as well. A method, that is what we're going to talk a lot about tomorrow, next lesson, which is on Monday. So on Monday, we're going to talk a lot about methods. A parameter is the information you put between those open parenthesis and close parenthesis. And when you create an object, you go open parenthesis, close parenthesis, and sometimes you don't put any parameters in, and other times you put a lot of parameters in. So it just kind of depends on what you're doing, whether that happens. So there's parameterized constructors and non-parameterized constructors. Both will work. One will create a student with default values. Others with this empty, the values would be null, and we'd have to put those in with what we call setters. Dot operators are a big deal, and we're going to start using them. That's when we write the name of the object with a dot, and then the action we want to take, like toString or getName. You are going to have homework to read that chapter 2 of Head First Java and answer the questions. The Google form is in Google Classroom. So just so you can see where that is and what I've done, I'm just going to show you real quick before we go to our game, kind of a fun way to end class. I have added a new category called Using Objects. Here's today's lesson. Here's the reading and assignment. The way the assignment is organized is there's a form you open. When you open that form, you're going to share this tab. You're going to have a, oops, sorry, I have to go to preview mode. You are going to have a PDF that you need to access. All you need to do is click on this link. I'm sorry, it's not hot. I don't know why it's not, but it looks like you have to select the link and paste it down to get to the text reading. And I'll just throw it down as an example so you can see what it looks like. Here is the chapter, and it does look pretty intimidating that it's long, but look at how much of it is just fun stuff, not stuff that you have to actually read. A lot of pictures. By the way, there are some activities in there, not required. If you want to do them, that would be really overachieving. That'd be great, but you don't have to do these activities, but they are there. You are not going to have to memorize this yet, but there will be a day where you do have to memorize how a class works. They give you a game that you can type in using Replit if you want. So some cool stuff you can do. Just change the name of the class, the class name. You have to have the class with the with the main method has to be called main. That would be the thing you would have to change to make that work. So whatever class has the main method has to be called main according to Replit rules. So that's your assignment. Now for fun, we have a GIM kit that just reviews the vocabulary. I am going to fire it up and ask that everyone please use their real name. And this is going to be the last thing we're going to have time for today. Just a little GIM kit. I'm going to stop the recording.